So I've got this code cut and paste off the internet, and it just plays a simple tone. I've also got this sheet music, Prelude and Fugue in C by Johann Sebastian Bach. I'm going to try and modify this program to play this music. So first I'll quickly explain what this code is doing. So the main method is just calling Bach, as I've called the class, and tone, and that takes three parameters: the hertz, which is the frequency of the note, the millisecond time to play the note, and the volume. So if I run it 15,000 hertz, 1 second, and a volume of 1, I get that, but I could modify it to just play half a second, and I could modify the note by changing the frequency. So what the code's actually doing is it's making a sine wave here and playing it through the data line, which is got from the audio system. So this sine wave is making that very pure tone. But what I'd really like to do is play the sound of a piano. So let's see if I can modify it to play a piano note. Okay, so I've loaded Audacity and I've selected Windows Wasapi here, and I've selected the speaker's loopback device. So I'm going to record what is played through the speakers. And I can find an open source piano sound and record it from Audacity. So I found this website, Sample Focus. It says we're free to remix, transform and build upon the material for any purpose, even commercially. So this is an open source sound library, and here we have various piano sounds. What I want is just a single sound. Here we have single piano notes, and I'm just going to record the sound of piano note C. So I'll go into Audacity and record this. Okay, so I want to export this piano sound in a raw format. Apparently I could do this by saying export audio, other uncompressed formats, and raw headerless. So now I'm going to modify the code to read our raw file into a byte array, and then I'll play that back through the audio system line here. So here I'm adding the read file method to read the raw data out of the piano sound sample file, and I'm modifying the for loop to use those bytes. I'm changing the step in the for loop to select bytes out of the file so I can play back the piano sound in different frequencies. Now I don't really know what I'm doing here, but if I play it back every 10th byte, it sounds okay, and if I play it back every 12th byte, it sounds okay. But if I play an odd number of bytes, it sounds wrong. And I think that's because it's recorded in stereo, and probably every other byte is left and every other byte is right. So when I record the sound, I'm then going to convert it to every other byte. So just by varying this number, I should be able to change the frequency. So I'll do that now. Now I know a little bit about the science of harmony, and I know that pianos are tuned to something called equal temperament, and that is the distance between the notes are equal on a sort of scale, but each octave is double the octave above, which is why the notes sound good together, because the sound waves don't clash. So here it says the notes need to be divided by the 12th root of 2. So if I just take the 12th root of 2, which I've got in 12th root of 2 is this number. So what I'm going to do is I'm going to take a bass frequency, and then for each note I'm going to multiply that bass frequency by the 12th root of 2, and I'm just going to play through a scale. Now a scale will be the white notes on the piano, and I want to play the white notes from C, so I need to play the 1st, the 3rd, the 5th, the 6th. Yeah, well, we'll see how it sounds. No, I don't know whether this is going to work. That worked really well. So now I will want to, I'm not sure how many octaves I need for this this music here, but I think I'll give myself the option to play through maybe 4 octaves. So I'll add some more notes, and then I'll do something to control the length of the sound. So here I'm adding an octave parameter to the play note method, and also making the method play the notes in a separate thread so I can play multiple notes at the same time. Okay, so 7 notes. Yeah. Okay, so now I need to take this sheet music. Well, first I need to be able to play a note for a certain amount of time, or rather I want to be able to play the notes when I want them to be played. Okay, so I'm going to create some sort of data structure to store the tune, and then something to read that and play back the tune. Okay, so I've made a note class which has got a key and a duration. The key is going to, well, it's going to be note and octave, and that's going to correspond with the notes we had up here and which octave we want it in. And I've also added another variable 0, which is silence, so I may want the note to be nothing, and a duration. And then I've made a voice class which is a list of notes, and that may be silence, but that's going to correspond with one line out of the sheet music. So there's 2 voices really in this music. This is played at the same time as that. And then a tune is going to be a list of voices. So I think this entire music is 2 voices. But having said that, there are some bits where several notes appear on the same is it called a stave? I don't know, the same set of lines. I'm not a musician, by the way. So I may need more voices, but the first thing I want to do is just get one voice working. So let's do that. So just as a test, I've created my class Bach tune, which is a tune. I'm going to give it one voice, and that's going to play C, D, E, F for 1 unit of time each, and then silence for 5 units of time, and then G, A, B and C in the higher octave. So now I'm going to just add that voice to the Bach tune, and I'll write the code. I'll make it another voice as well that just plays just a couple of notes at the beginning, and then I'll write the code to read the tune and play it. Okay, so for the timing, I'm adding a get millis method, which is just going to create a new date and get the number of milliseconds past the 1st of January 1970 Unix time sort of thing. And then I'm going to feed that into the voice player. And I think a unit of time will be a quarter of a second. Let's try that. So I'm going to define a constant time unit, and I'll make that 250 milliseconds. So when we play a note for a duration of 1, that means play it for 250 milliseconds. I may speed that up or slow it down, we'll see. So I'm going to make a method play voice that's going to take a voice and a time which starts off as a start time, and that's going to start a new thread so we can play several voices at the same time, and that's just going to read the notes out of the voice, play the note and wait until the time is the duration of the notes time multiplied by the time unit. When that amount of time is passed, we'll add that to the time. We'll add those number of milliseconds to the time object and play the next note. So that's something like this. So I'm adding a new thread for each voice, but because they're all synchronized from the system time in the date object, I'm hoping they all stay in sync. Okay, that's awful. Okay, so I'm going to call it a day for now, and I'm going to come back soon and have another look at it tomorrow. Okay, so this is day 2 now of working on this this music program. Today I've started to draft the first bit of the song, and you'll probably recognize the tune when it plays, but it's just not working out. Really, I think that I'm in the voices, I'm having a separate thread to play the voices. Here's a thread for each voice, and then I've got a separate thread playing the notes of the tune. And in the tune, I've got notes which are just being played for 1 unit of time on voice 1, and in voice 2 I've got notes which are being played for 1 unit of time and notes which are being played for 7 units of time. If I just cut that, so these should line up, but when we play it, it's not quite working. It the tune just carries on now. Basically, I'm not happy with the timing at all, so I'm going to quite drastically change the way it works. So, lesson learnt, I'm going to try and avoid using multiple threads, and we'll see if I can improve things. So I'll make quite a few changes now, and then I'll explain them when I'm done. Okay, so after a bit of messing around over the course of a few evenings, this is what I've come up with. So first we have an instrument object that will read the byte raw data file into a byte array when it's initialized. We have a get bytes method so we can get the data out of there. This also handles the thing where we split up the stereo channel. We then have a channel object. This has got an open and close method which sets up the data line and shuts it down, and then it has a set note method. That set note method will, if the note is not null, it will play the tone by starting up a new thread and setting the data line buffer to be the entire note sample. It will flush the data line at the beginning of this new thread operation, so if a previous note is still playing, it will cut that off and play the new note. So that channel will handle one voice of the song. Then we've got a player object. Now this just handles all the channels, so we can set up the player with the tune and the instrument, and then we can start and stop it. That just loops through the channels and starts those up, and loops through them and shuts them down. And then there's a tick method. That tick method, we tell it what time it is in the song, and that will loop through the tune, get the appropriate note for each voice at that time, and send it to the channel so it will play that note. Then the tune is pretty much as it was before, so we've got the note. That's got a list of notes. Now I've kept this as integers because it's used to calculate the frequency of the note. So we've got the note, the octave, and the duration that the note should go on for. And then we have the voice object. Now the voice object's got a list of notes, but it's also got this new time notes thing, and we have a schedule method. So what we do here, we set the notes and then we call schedule, and what this loop does here is it's going to work out when the notes play and put them in a map along with the time that those notes are supposed to play. So when we say get note at by the player, we'll get the note that should be playing at this particular time. And then finally we've got a tune that's got a collection of voices, and the only one additional method we've got the initialize that will call schedule in the voice to set up the map of timings, and then we've got a get total duration method just to tell us the total duration of the tune. And then finally back tune extends tune, and that's got the notes input from the sheet music. Got 3 voices because I realized when I was inputting this in that the 2 notes are held throughout the bar. Other than that, much of this song is just the same pattern again and again. And then the main class, which is just called Bach, just sets up the tune, loads the instrument, the piano, and it starts the player, and then it's just got a loop, and it just ticks through the loop from the start 0 to the end song duration. And then I just do a thread sleep for a time unit. 120 milliseconds seems to be about the right tempo for this song. So let's have a look at what it sounds like. So that sounds about right. So now all there is to do is enter the rest of the song from the sheet music, which is going to take some time, and then I'll play the final version. Okay, so that's it for now. If you've enjoyed the video, give it a like, and if you've learned something and you want to see more videos like this, then subscribe to my channel. Thanks for watching.